But yeah, I'm Bob Ward. I'm an architect in the Microsoft Azure data team, and have been now at Microsoft. Boy, I'm afraid to admit this. I'm sure there's somebody in the phone that's younger than I've been at Microsoft when I say this. That's my 28th year. So this October will mark the 28th anniversary of me joining the company. And I focus my efforts on SQL Server, Azure SQL, and quite frankly, anything with the word SQL in it. That's kind of what my jam is, working in the engineering team. So thanks for having me here.
Congrats. Thank you. Anniversary.
Congratulations.
Thank you. Yeah. Well, why don't I share my screen if that's okay? We get started. Will that be all right with y'all?
Please.
Sure. So let's see. Let's share this and make sure you can see it. Let me know if that works for you.
Yes, we see your PowerPoint.
Yes, we can see it.
Let's go ahead and start presenting here. And it's really good that you asked me a little bit about me and what I do, because it's a great way to start up this conversation, SQL Edge to Cloud. Like, why? What's this SQL Edge to Cloud thing? Like, why would you create a presentation called SQL Edge to Cloud? And what happened was, probably maybe late last year or so, working with my team, doing lots of different things of SQL across the board, it kind of dawned on me about this term, that SQL Server now is showing up in so many different form factors in so many different ways. Should we explain this to everybody about how many different ways SQL is out there? Which one would you pick when? And why would you pick when? And so kind of was born this idea of presenting SQL Edge to Cloud. So I didn't really start doing this until this calendar year. I think I've done this maybe one other time, and you'll probably see this show up in other ways and forms in the rest of this calendar year, because I think it's important to make sure you have this message. And probably the right way to do this to start off and talk a little bit about the history of SQL Server. But before I say that, you know, this is not 1,000 people, and we're here online technology, so let's definitely make it interactive. I'll find natural places to pause along the way, and I'll stop and I'll look at the chat window, or I'll just see if you have verbally some questions you want to ask, because I definitely don't want you to walk away from this evening and not have questions answered. Now, one thing I will tell you is I will definitely provide an answer to every question. It may not be the answer you want to hear, but I will provide an answer to every question. This deck is actually already on this website you see right here, AKMS Bob Ward MS. In fact, when I presented a different presentation and put this link up there, somebody pinged me after the fact and said, oh my goodness, you have presentations up here for like the last 15 years. So if you want to go up there and just grab a deck, and by the way, I'm an open source presenter. Have you ever heard of that term, open source presenter? Everything is yours to use and reuse. You can take anything up there that you see, and you can reuse it in your own presentations that you will. My only request is if you have questions about presenting it accurately, you just ping me about doing that. So let's talk a little bit about the history of a SQL Server. We won't go too far into this, but it sets the stage for why SQL Server now is edge to cloud. So let's have some fun. I posted this on social media. I think I did this yesterday. I'm not a social media person. I am no Buck Whitty or Anna Hoffman. They are like the masters of social media. I'm a mere mortal when it comes to that. But one thing I posted is that SQL Server started out on desktops with diskettes. Some people don't even know what that is actually. Can anybody go ahead and maybe you saw this posting on social media, but does anybody know how many diskettes did it take to install SQL Server on OS2? How many diskettes did it take?
Oof, maybe more than 10.
10, okay. Anybody want to start throwing some answers there in the chat window? Just put some numbers out there. 200. 200, okay. That would be a daunting task to actually put in 200 diskettes into the diskette drive. Anybody else want to take a shot? 32, okay, 32, you know, a little more reasonable. Come on, let's go, come on. You didn't know you were gonna have to do anything tonight. You're like, I just want to sit back and sip on a drink and listen to Bob. Okay, 21, 40. Anybody else want to take a shot at this? 12. Okay. All right, so I happen to have them in my hand, and the answer is 2. Can you believe that? So right here is SQL Server OS2. I don't know, you probably can't make that out on the camera there. Maybe you can. SQL Server OS2, it's the real thing. 2 diskettes to install this product that you now know and love. That's an enterprise force in the industry. And it's kind of crazy. The story really goes is that last summer, we're redoing the Microsoft offices in Texas, in Las Colinas, Texas. They're reconstructing and remodeling them. It turns out it's a great time that nobody's actually in the building because they're remodeling the buildings. So I had an office there, but they're going to go to more of an open concept. Isn't that ironic? And so they told me you have to move all your stuff out. So I went in literally last summer for a week, went up there and cleaned out my office. And down, lo and behold, in one of my drawers, yeah, I had an office with actual drawers. I found this. This is so old that the rubber band had stuck to the diskettes. Like you couldn't, I had to pry it off there, right? But I thought that's amazing to show where we've come from and the fact that SQL Server really started out as a desktop product. The maximum memory that SQL supported back in the days of Pentium computers, anybody what a Pentium computer is? 16 megabytes. That's the max memory on a 5 gigabyte hard drive. But guess what? People ran their businesses on that. Can you believe that? Like a doctor's office would run their business on SQL Server using that. But what led this in this evolution, and you think more about the SQL 7.0 timeframe, is this concept of a department server. So companies, as you may know back in the days, it's all client server driven, would take their department, the finance department, for example, the HR department, and they would have their own server. They would not really be connected that much to everybody else. They'd have their own server, and SQL became very popular for a couple of things. One was easy to use. Number two was price. It's cheap compared to that company that starts with an O, right? So SQL very popular back then. SQL 7.0 was a landmark release for us because it was almost a rewrite of the SQL engine from what we originally had, which was based on the Sybase product. Now you move forward to even like SQL 19, right? Even today, and SQL Server's a force in the enterprise space. I don't know how many times I heard this over the years. SQL Server's not enterprise ready. Well, why don't you go see who leads the benchmarks across the board? Who's the fastest benchmarks of databases in the industries? It is enterprise right there. Now, that's interesting, but SQL Server could not survive and SQL as a product if it didn't go to new areas, kind of like a Star Trek movie, out to new parts of the galaxy, right? So along comes this project called Azure. Back in the mid-2000s, we started this way back in the mid-2000s. If you will go, I'll give you resources in this talk, but you can have some really fun watching Ann and I talk about what is Azure SQL, and we actually cover the history of this. I wrote a book. It's right here in the background here. We'll also point that book out. And the whole first chapter is about the history of Azure SQL. So it goes way back to mid-2000s. But now SQL running in a public cloud became a big deal, even in Azure virtual machines. In fact, you may not know, maybe you do know, but the most popular way to run SQL Server in a virtual machine today is on Amazon. Amazon virtual machines are the most popular form factor to run SQL Server in the cloud today. But of course, SQL Server has our own platform as a service, and we'll talk certainly a lot about that today. Now, we did something very interesting in 2017. We had to go all the way to Satya Nadella to get approval to this. How about Linux? We made this decision, and this project actually started back in 2015. We made this decision to run SQL Server on different operating systems than Windows. Funny story is that back in the day, as an employee of Microsoft, we tried this effort many different times. But I remember seeing in 2015 us getting approval to do this, and we went to the market very quickly. We'll talk a little bit today about why SQL is effective to run on this platform, especially in containers. And then finally, SQL Server has always been thought of a database, a relational database system, a relational database engine, which is all true. It's really a data platform. What other data platform, what other database engine can you run machine learning algorithms in place with the database, right? What other database engine provides data hub virtualization type capabilities? What other data engine runs on with Spark and Hadoop with it, right? So SQL Server now becomes a data platform to meet all your data needs versus just being an engine. But it is important for one concept you to keep in mind. There's a proven engine behind this thing. You can tell that I paid a lot of money for the graphics on this slide right here, right? Big expense went into the graphics right here. But keep that in mind, that this proven engine has been iterated over and over many different years to power all of this. And what that leads to is the following set of assets. I use this term for you, assets for SQL. And it all starts with what you might run in your data center or devices that are not in the public cloud. And it could be Azure SQL Edge. We'll talk a little bit about that today. Why is this important? Why did we do it? But imagine running SQL Server now on a drone, for example, or in a manufacturing device. That is Azure SQL Edge. So something running on the IoT Edge itself. SQL Server 2019, the latest version of SQL Server we produced in the fall of 19. I still find myself on presentation saying, hey, y'all remember last year when we launched SQL 19? Oh, wait a minute, that was actually a year and a half. Yeah, I mean, don't we all just make the mistake of saying last year? Because like this year that went by, right? But anyways, this November 19, we announced SQL Server 19. We'll talk certainly about that as well. And then SQL Server on Linux really opened up a lot of possibilities for us at Microsoft and for our community. And that is to be able to run SQL Server on different operating systems with containers and also in something you've heard of probably called Kubernetes. Now, what about the public cloud? We have a branding that we started last year, a branding of a name of a suite of ways to run SQL in public clouds, and that is Azure SQL. So you have SQL on Azure Virtual Machine, again, could be Windows, could be Linux, could be containers, Azure SQL Managed Instance, and Azure SQL Database, which can be in pools, hyperscale, serverless, all sorts of form factors. So already you can just see by looking at the slide, SQL is running in all sorts of different form factors in different environments for different reasons. Last year, we also announced public preview for something called Azure Arc. This diagram starts to get pretty busy now, right? Azure Arc enabled SQL Server is a way for you to attach your existing SQL Server to the cloud, hence the term Arc. And then Azure Arc enabled managed instance is literally bringing the experience of platform as a service to your data center using the power of Kubernetes. That is currently in preview right now, these forms of SQL. And notice these symbols in the middle, connecting things like Azure Defender and the Azure portal to look at things across all of your assets. When I've shown this to somebody, in fact, I was showing it internally to our team, they're like, Bob, this is crazy talk. Like, how do I figure out all this stuff? And it probably means I've got to learn a bunch of new things. Well, here's a couple of things that might give you some ease about what you know today and how you can learn these things. Number one, the core engine for performance, security, and availability are the same across these. Now, it is fair that in some cases, there'll be a slight difference. Or for example, we'll talk a little bit about the two at the right-hand corner up here are versionless, where the other ones are versioned, right? Although our intention with Azure Arc also is to make that kind of a versionless idea. The same core engine, let me get an example. Slava Oaks, who now doesn't actually work on our team specifically right now, he's actually working on Azure. Slava Oaks told me one time we were talking about Linux. He said, Bob, the query processor that you know and love in Linux is the same exact bits of the query processor you run on Windows. The query processor in all of this is the same. Column store indexes runs on every one of these things. You can take a backup on any one of these things and restore it on any one of these things. Yeah, okay, you got me. There's a few differences there. Like the version lists don't support that as much. We'd like to change that actually, by the way. But you can take a backup on Azure SQL Edge and restore it on SQL Server and Azure VM if you want to. So there's a lot of compatibility to same core engine. You're a developer and you're like, look, this is too many things to learn. No problem. These languages which you know and love work on these assets. Of course, number one being T-SQL. If there's one skill that all of you have right now, probably it's T-SQL. And that works across everything we ship. In fact, you'll find, and you've seen, when we extend things a little bit on our data platform, how do we do it? We extend the T-SQL language. We have T-SQL extensions in the cloud for it. We have T-SQL extensions for machine learning, things of that nature. So having those robust T-SQL skills are very important still for your career skills. And then finally, the tools that we've built work across this, whether it's the new Azure Data Studio, which we'll see today in a demo, Management Studio, PowerShell, SQL Command. So common languages, common engine, common tools, but SQL running in way different crazy things. Now, you're the first people to see something today. At the very end of this slide, I built a table. Everybody has to have a table, right? I have a table where I'm going to give you some suggestions, and you can look at the deck later, of how do you pick one of these options depending on the scenario you want to solve. So it'll be interesting to get your feedback once you look at this table on how it'll help you. So let's do this. Let's take a journey, if it's okay with you, to go through some of these things and talk about them a little bit more depth and see some demonstrations. But I also want to stop and see if you have any questions at this point.
Hey, I was just wondering if you're going to cover any of the actual SQL Edge micro devices, like running it on a Pi or a Raspberry
Yeah,
Pi.
thanks, Jeff. We'll talk about SQL Edge at the beginning here. Let me see if I've got this. Yeah, sure. So we'll talk about this in a second, but I'll talk about the fact that I've installed it on this bad boy here. So yeah, we'll talk about Edge. We're not going to do a lot of deep diving into all the different devices, but I'll answer your questions there on where would you run it, how would you run it, and that kind of type thing. Anybody, any other questions that you have before we get started? Okay.
Feel free. Okay.
That's okay. Hey, we'll pause for another second here, see if anybody asks questions. Maybe your head's already exploding. You're like, what the heck is this going to be about, right? But hey, Jeff, great segue. Let's start talking about the Edge. So Jeff and others, here's the storyline. A couple of years back, we were starting to talk to different people in different industries, our partners, especially in hardware spaces. And what we were hearing is this: IoT is amazing, right? I mean, think about all the different ways that people have devices today that generate telemetry, sensors, you name it, right? The problem is this: what we're hearing is that a lot of these devices are generating so much data. Just raw sending this to the cloud, for example, is not all that effective. Now, there are edge devices like hubs that can help, right? But we're also finding out people saying, look, I'm in a semi-connected environment. Like I have these sensors data. Where am I going to store all this stuff when I want to get connected? I would love to be able to push processing power down to this. Like, can I collect data and at the same time analyze data and do stuff on it? A great example for like machine learning, maybe, that'd be kind of cool, right? So we said, SQL Server is a pretty good data processing engine. Maybe we could do something with that. Now, we had a couple of challenges. Number one, what are a lot of these processors that run these devices? They're ARM processors. SQL doesn't run on ARM. That's one issue. Number two, the footprint of the SQL engine is quite large. And even though these are getting larger and larger with their footprint, we needed to be able to find a way to run SQL in a very streamlined fashion, but still have all the core capabilities. Thus was born Azure Sql Edge. We found a very clever way to be able to run a SQL engine that we compiled for Intel processors on ARM processors. Quick funny story behind the scenes there is that we partner with the Xbox team to make that work. That's kind of interesting. It is not an emulation, by the way. It runs extremely fast, and we've proven that by how we show our demonstrations on it. So we got it. We figured out how to run on ARM. Then we went through a very, very interesting exercise. So I love movies. I don't know about you guys, are like a movie buff type person. And there's this interesting movie called Pearl Harbor back in 2000 about the history of kind of the attack on Pearl Harbor in World War II. But the interesting story is when the U.S. Bombers were on the aircraft carrier trying to send their bombers off a carrier, which was unheard of. Like nobody could do this, right? They had to find a way to strip it down. And they were literally taking the guns out of the plane and putting painted black broomsticks in there to make it look like a gun. So somebody thought there was a gun in there, but they had to make it very lightweight. They had to make it so small and lightweight to run and land off an aircraft or launch off an aircraft carrier. That's what we did. We went into our code and said, do we really need that? I mean, SQL had been built up over the years with a lot of stuff in it. How do we find a way to reduce the footprint for a streamlined engine that's still very powerful? We were able to take the SQL Server engine and run it in less than 500 megabytes. That's like crazy stuff for our engine. But we need to do other things. We need to put in things like time series and data streaming and machine learning into this thing directly. We needed to have data movement as part of this. We need to be able to run on ARM devices. We still need to have security and performance. Like, how are we going to pull this off? This is where containers come into play. We found through our studies that most of these devices could run Ubuntu as an operating system. Well, it just so happens that we already had done that. We had learned how to run SQL on Linux and containers. So we have found a way now, to deploy containers on a like ARM device that includes the SQL engine, things like Kafka streaming, and then we took the engine and enhanced it to integrate with that. So now I can go take this, I can deploy Ubuntu and SQL containers on here with Kafka containers that we've got integrated. I now then can take any APIs that are possible to run on here to collect, like, say, sensor data, telemetry data. I then can run T-SQL commands to directly pull in Kafka of streaming of the sensors. Then this gets really interesting. I can do stream analytics on the fly on the data. So like I can have this little thing produce a lot of information, and instead of actually running really hardcore queries, I can run analytics as I stream it to pull down only the data I want. Then I can take a machine learning model and train it somewhere, maybe in the cloud, maybe on SQL Server, maybe in big data clusters. I can install a model on this. Then I can do predictive analytics directly on the device. You're like, say what? So we've demonstrated with companies, and this is very popular, we've demonstrated with organizations that are very semi-connected, like in, say, a mining company where they have devices. We've demonstrated where we're able to take machine learning models, push it down to these devices, and they can do very reliable fault prediction for their manufacturing devices before they really need to be repaired in a very economical way. And we're doing all that directly on the device without sending any data to the cloud, which is pretty cool, right? Now, we still can send data to the cloud with this, or you can maybe send the results of what you did to the cloud. So you still have this connected environment, but look at this develop once, deploy anywhere mentality. It's all still T-SQL too. I could build the entire application with everything I just showed you outside of the edge and then just go put it all on the edge device and then just run the thing. So extremely excited to see this technology. It's now generally available. We have several big, large companies that are part of their business is IoT type devices that have come to us and said they're really excited about being able to run this technology. Jeff, does that answer some of your questions you had?
Yeah, no, for sure. And I kind of knew that. I was hoping for more of a, I guess maybe a detailed dive. And are there any published use cases of this out there? Because I've been looking for like some MVPs who have been doing this, but I haven't found very many who have gone through the weeds and have examples that to play around with, train others.
Yeah, and sometimes when I've done this presentation, I have a demo to show you of this. I don't have that tonight. But it's okay. I can give you all the details you want and more. And I can even put you directly in touch with our team that works on this to answer all your questions.
Cool. That'd be awesome.
So do this. This is part of having a small group here, right? So here we go. Why not just hand out your email address? So Jeff, just send me an email and I'll give you all the resources you need and put you in touch with the team as well.
All right. Awesome. Appreciate it.
Sure, they'd love to talk to you. But that's Edge. I mean, that's this first part of what we're doing. And again, remember, this is the same SQL engine you know and love that's running in these devices. So you may have heard, and Cecilia, you mentioned you've seen me before present, but calendar year 19, well, starting from the fall of 2018 all the way until November 19, Diana mentioned about traveling. I finally went back and looked at it, back in March of last year or something. I traveled 52,000 miles. Around the world talking about this slide. I call this my camera slide, and it's because everywhere I went, everybody wanted to take a photo of it because it's a visualization of what we produce with SQL 19, which I thought was just an amazing release for SQL as a platform. And so let's talk about all these kind of things a little bit, and then we're going to drill in. I picked one specific scenario I think hardcore SQL people will love, and we'll see a little demonstration of it. First of all, we started in this journey of 19, and if you want to know a little bit of the story, we started working on this before we'd shipped SQL 17, actually. And the dream was, can we go out there and make SQL a data hub? Can you use T-SQL to query data where it lives instead of moving the data? So you look at all these icons right here, could we all of a sudden run SQL? And we started that journey with something called Polybase in SQL 16, but it was very limited. So now we said, hey, we would like you to run queries in SQL Server that will access any of the things you see here on the screen. You could even join them together, but I don't have to move data now, right? We'll use this concept called Polybase and external tables to make that a reality. And we kind of took this a step further and went a little bit crazy. We allow people to deploy something called a big data cluster, which uses Kubernetes to deploy containers where we will go ahead and deploy Spark and Hadoop in the Kubernetes environment directly and allow you to use the power of SQL to go after those resources in your cluster. Well, if you don't really want to do that, we still provide Spark connectors and machine learning services built in and other endpoints to go deploy machine learning models. So the customer stories behind big data clusters, it's interesting, and there's case studies out there for this. They typically involve companies that are big into machine learning. They're using it as a complete machine learning platform. And here's what they told us they love. They love the fact that it's contained and secure. a lot of times they found their data, their big data, was very unsecure. We even saw that from talking to customers around the world. It's like, hey, let's talk about where your data lives. And they're like, oh, I think somebody has a Hadoop cluster over here. And we're like, well, who manages that and who gets access? Oh, everybody has access to it. I'm like, well, what's on there? Yeah, we're not really sure. We think it's important. I was amazed people admit this, right? We're like, hey, we have a very secure environment using the power of SQL and security, high availability with availability groups and Kubernetes that can solve your needs. So data virtualization became a big concept of something we shipped with SQL 19, big data clusters, an extension to that story. If you look here in the middle, this was us making sure the world knew, and you saw the edge to the cloud that kind of confirms this, but us being able to run SQL on all these different platforms now with compatibility, and what we mean by that is not just app compatibility, but database compatibility. Taking a backup, restoring it anywhere you want to go. We had customers that made the shift running Windows to Linux because that's just what their company was doing. And the shift was as simple as backing up a database and restoring it and just starting to run is what they did. So containers, Linux, Kubernetes, ARM devices, that was a theme for us. And then machine learning and extensibility, you may have seen us, I talked about being able to do it on Edge, but we started this in SQL 16 with R processing co-located with SQL, added Python to the story in 17, and then we added Java in 19, for gosh sakes. All in a very extensible way, in a very secure, isolated way. People don't realize they get a little bit worried when Buck Woody is allowed to run his machine learning model on your SQL server. People freak out. They're like, I can't let Buck do that. I hope Buck is listening, or hope you tell Buck I said that. He'll get a kick out of that, and he'll probably admit that it's true. But would you really like somebody to be able to do that on your production SQL server? Well, this is a very isolated, extensible, secure platform where you really can control how things are run in a way that you shouldn't be concerned as much about doing that. If you look at this top part of the screen, this is like crazy talk for database engine people. They're like, what is all this stuff? This is a platform, is what it is. But you're also saying to yourself, you said that this engine was a really cool engine. Didn't you really invest there? And we did. You can see it in the bottom layer here. Intelligent performance being really important to us. And that is, we want you to get faster and not make code changes. And that was a really big theme for us. And we achieved that a lot with intelligent query processing. Imagine you having stored procedures with table variables, and you're like, look, this is just terrible. All the way you guys do, cardinality estimation's bad. How do I get faster here? How do I diagnose it? And just go to latest compat level, and you can get faster. Sorry about that. Security, we moved forward the story about always encrypted with secure enclaves now. And then data classification. If you're invested in GDPR or other classification reasons for compliance, classification is really nice because you can classify columns and label them and then go do auditing based on any queries that touch those columns. We've demonstrated that before. And then accelerated database recovery is just this crazy, amazing story. So what I'd like to do is kind of pivot and talk specifically about that one and then show you a demonstration. And when I show you the demonstration, I'm going to show you a resource you can use to go demo any of this stuff. You can try this all out for free with Developer Edition on your laptop. So let's have some fun here. Let's have some fun with this story. Let's pick on, Bob gets to pick on colleagues that aren't here on the call. That's really a fun thing I get to do when I present to user groups. And that is, and I love picking on Buck and Anna, and let's pick on Ree Irish. Yeah, let's do that, right? So let's say Buck Woody comes along. Jeff is on the phone, Jeff Taylor, he's managing this business, and Buck comes along and he runs a transaction to delete 1 billion rows, okay? And he just runs this thing. He somehow got permissions to do it, so he runs it. And Jeff realizes the business has come to a halt because Jeff has blocked the world. I mean, Buck has blocked the world. This is really bad, right? So this is an issue. So Anna is really clever, Anna Hoffman. She's like, hey, I got you, Jeff. I'm going to solve this problem for us. I'm a very smart person. I will kill Buck. I mean, not Buck, but his session. I'll kill his session. So she goes in and does a kill command on his session. She really wants to strangle him, but she kills his session, right? Well, what happens is that Buck's session that he did goes into a rollback state. This is really bad, right? Jeff is still really mad because the business is still down. Now, Ree is really clever. Ree Irish, super smart person. I know Ree personally. She had read somewhere that Paul Randall said, if you just crash SQL Server, just go kill the process, it'll just come back up and everything be great. So that's what Ree does. Trust me, I'll crash SQL. She does. And Jeff's still mad because like 20 minutes later, it's still not up. The database is totally down. And in the error log, it says like 1%, 2%, 3%. This is really bad, right? And it turns out that Ree is really embarrassed because she also manages the transaction log, and this whole time the log's out of control and ran out of disk space on the drive. This is really a disaster. Do you know that for 15 years of my career at Microsoft, I probably receive a phone call like that story right there about once a week, at least, okay? And so the problem being is that if things are done in a certain way, rollback and recovery times can really be a pain to your business. Along comes this really amazing technology called accelerated database recovery. And the project name for this was actually called constant time recovery. That was the goal for us. So here's how it works. You enable this as a database option in SQL Server. In Azure, it's on by default. Okay, when you do this, when you enable this, we will use a persistent version store in your database to record versions. Now, this is independent of locking and isolation levels. We still honor all of that stuff. We do not use the version store in TempDB anymore. We use versions in the database. Rollback now runs so fast. I'll show you a demo in a second. You don't even know how fast it ran. It just runs. So rolling back 1 billion rows is as fast as rolling back 1 row. Undo recovery is so fast now that, you know, the little percentage I told you, sometimes we don't even print that anymore because it just happens so quickly. And then transaction log truncation is not tied to the active transaction, whether it's something that somebody deleted 1 billion rows or they started a transaction and went and got coffee, right? Now you're looking at this going, this can't be happening. Like, this isn't even, how can you pull this off? It must not, there must be a catch to this. And you have a lot of questions. Does it require more space? Will it be slower? Will I still see versions in TempDB? And does it even work with things like AGs? A key to being a good presenter is to put the burden on someone else to answer your questions. So all of those questions are answered by reading this white paper. Now, I will tell you that I can give you all the details behind this, but the fact that we have this on in Azure and you can't even take it off tells you that we believe this can really be something that you can turn on and you can run this in production environments and it not affect what you're doing in your business. This paper is lovely because the team that built this, the developers, wrote the paper. They did it as kind of like a computer science ACM paper. And in there, they do experiments to show you all the details behind how much more space will it take, would it affect your performance, how much would it affect it, and answers to these other questions here. The always on availability group questions are a really great story there because people don't realize that if you do a read replica in AGs, when you run a query, we are using the version store TempDB with snapshots. That's the default. We have to use snapshots to make that work. Now we'll just use the version store in the database, so it runs in a much more faster fashion. And if all your databases use this feature, you will no longer see versions in TempDB because all the versioning would be done inside the database itself. And it is the thing, one of the biggest things that we use in Azure SQL to meet our service level agreements. So pretty crazy technology. Let me show you a demonstration for a second, then we'll stop and see what questions you have. So let me flip over here, and I'm going to pull up, let's see, here we go, Azure Data Studio. Has anybody ever seen Azure Data Studio before? Hopefully by now you may have seen this. You've seen a concept called a notebook. A notebook being something we pulled from the data science industry with specific notebooks that they use for data science purposes. We've built a T-SQL kernel for notebooks. This is a combination of markdown text along with cells of SQL code. Now, what you're going to like over here is, this is a folder of a GitHub repo that I pulled down locally, and these are all modules in SQL workshops that you yourself can go do. So if you want to go try out all the great things about SQL 19, you can go right down here and go do anything you want, and it's all free. Pull down the GitHub repo, install SQL Developer Edition, and go try out all these things. And then all the instructions in the GitHub and in the code here, like in notebooks, have instructions on how to do it. So this is the way it works. And one of the cool things about notebooks that I actually love is the fact that you can run them, and then the output is saved in the notebook. So great presentation tip. If you're going to do demonstrations, and you want a backup plan, use notebooks because you can just show the results of what you did without running anything. So in this example, I'm going to create a database called Go Cowboys. I'm sorry, this is South Florida. You probably aren't Cowboy fans. You're probably booing right now, want to throw things at me. I get to do my demos, so there you go. Anyways, Go Cowboys is a database. I've got about 100,000 rows in a simple table. And what I'm going to do is I'm going to come along here, and I put some rows in there. I'm going to do what Buck Woody did. I'm going to go turn this feature off to show you the difference between it being off and on, and I'll go delete 100,000 rows in a transaction. Well, let's go see how much transaction log space is used. You can tell here already that I'm using 91% of the log. Now, percent of the log. I can tell you this is simple recovery mode, by the way. So you might be thinking, well, I can just checkpoint to truncate the log because I'm in simple recovery. No, I don't think so. It turns out still 79% of the log is being used. And that's because you have an active transaction out there that's preventing log truncation. Now, you might want to go do a rollback here, like we were talking about that Anna did by killing it. We'll just do a rollback here. Notice this took around 11 seconds to roll it back. Why is that? Because without accelerated database recovery, we're still using these standard Aries algorithms to do compensation records. We have to go in there and put a bunch of inserts into the log to account for all the deletes. That's why it takes so long. And again, I'm only doing 100,000 rows. What if this was a billion rows? It could be crazy, right? Now, at this point, the log can get truncated because I rolled back the transaction and I can see that it's back to like 1%. So if I go turn on this option and do the same darn thing, let's look and see what the behavior looks like. Well, first of all, the transaction itself is a lot less time. It's like, what is happening here? There's a lot less that we actually have to log here because we're using accelerated database recovery, because we're using versions here. And then now, this is the point that's really nice. Look at this. My transaction log, even like before I used the checkpoint here, is not tied into the active transaction anymore. The log can be truncated because, again, we have versions inside the database. Now here, let's go look. I'm going to do a rollback now. And again, I'm sorry, but if you thought we were just going to sit back and listen to me talk, you have to be interactive. Can anybody put in the chat window what they think, how long it takes to run that command? Like the rollback with accelerated database recovery, how long will it take to run that? Anybody want to take a guess? It took 11 seconds before. You remember that? Come on, Cecilia, throw something in the window here. Let's see it. Less than 1 second. Cecilia, let's see, Jeff's going to try. I think Jeff's thinking about it. Should take less than a second. 10 seconds. Okay. Yeah, that's good. 3 seconds. Okay. Milliseconds, Cecilia. How about less than a millisecond? What do you think about that? Look at this. That's how long the rollback took. That's insane. That's absolutely insane. Now, why is that? That's because we don't have to do any of that compensation work. All we have to do is mark the version aborted and put a single record in the transaction log that was aborted. That's it. And that just basically shows you the power. If you go back and look at the PASS Summit 2019 keynote, which is, I'm sure, well, you know what? Now that PASS is not there anymore, I don't know if you can find the keynote anymore. Maybe Redgate kept all that stuff. But Connor Cunningham and I were on stage, and I showed a scenario where in the error log where I killed SQL, that sequence of what it looked like. And again, undo recovery didn't even show up in the error log. Like we couldn't even find it in the error log because it happened so quickly. Amazing technology. Go do all the workshops if you want to see anything I just showed you. What's really nice about ADR here, you will not be able to do this workshop on Azure SQL because it's on by default. You can't turn it off. So you can just try to go run the stuff yourself in Azure SQL and see how fast it is. Let's stop and see if you have any questions.
I don't have a question, but man, I love this. I actually had to use it this morning. We had a process that was going
Jeff
through
Taylor.
2 billion records, ran for 13 hours, and it came up this morning, and it wasn't done. So we just killed it, and it was less than 3 minutes, and we were all back in business.
There you go. That's a great testimony. I wrote a LinkedIn post about this during 19. And the LinkedIn post was how SQL Server saves the world from recovery, from long-running recovery, right, with ADR. So love the technology, very innovative. If you really want to geek out, you're like, look, I really want to geek out. I just feel like it today. Go read the white paper. It's got some really good information about internally how did we do this and why we did it. And we ran it in the cloud for like a year before we turned it on in SQL Server just to kind of prove what it was doing.
Hey, Bob, this is also not just save the world, how to save you from actually killing your coworker or something, right? Where was this when I was at DBA?
Yeah, poor Anna. She really wanted to strangle Buck here, but no longer.
Awesome.
It's funny when we were speaking in person 19. I always picked on her in the audience, and she was in the back, and I would call out on her. She's like, "Why are you picking on me?" I said, "Because you're just so nice." So. Okay, let's go ahead and move on and go back to our PowerPoint, and let's talk a little bit about containers. If you think about what we were doing, remember in our little SQL Edge to cloud world, we started with the Edge, we talked about 19, talked about containers, then we'll shift over and talk about public cloud, about Azure SQL. Lots of great stuff to chat about there. So if you've not used containers before, it's actually pretty amazing technology, but it's simpler than you think. I have heard people say to me, oh, container, that's like a lightweight virtual machine, right? Or isn't that some sort of special process that works with a container process, and a container thing works with your all sorts of myths. In fact, this diagram over here on the right, I think I'm going to use my laser pointer. Oh, look at that. I'm going to use my laser pointer. This diagram on the right over here used to have this runtime like right here. And I changed it when I first saw this, because that's not how it works. Containers are isolated processes that run in isolation, but they run on their native operating system. So a SQL Server container here is just a SQL Server process that talks directly to the host operating system. But the operating system provides constructs to let it run in an isolated way. So for example, on Linux, a container runs isolated in something called a namespace. You yourself can create a namespace in Linux and put a process in a namespace, and you can call it a container if you want to. In fact, machine learning services for Linux uses that. We take our Launchpad process and run that in a namespace. So the container runtime, Docker being the most popular one you've heard of before, it's responsible for creating these processes and namespaces. But at that point, the namespace takes over in the operating system to achieve this isolation model. Now, one of the cool things that containers can really provide you is portability. If you are today wanting to get rid of a server for developers for SQL Server, so I love all your developers on the phone, but I'm sorry, you mess up SQL servers all the time, okay? Let's be honest. You're all putting a bunch of databases out there. You're trying to change configuration. You all want admin privileges. Every developer wants admin privilege, right? Hey, I'm a developer, right? Give me root. I want it. Well, guess what? There might be a better way, and that is give your developers containers. What if you have developers, let's say in your organization, you have developers on MacBooks, developers on Linux, developers on Windows, all these different operating systems. Guess what? You can give them a SQL container image that looks the same, that runs the same in all three. You can even create your own custom container. Notice consistency here with a specific image of SQL based on a specific cumulative update, and bundled with it a set of scripts and tools that developers need. And they can all just go work off that version. They're lightweight because the fact that they're isolated processes, instead of using VMs to isolate SQL, use containers to isolate SQL. Therefore, you can put more containers in a VM. Here's news for you. Containers don't replace virtual machines. They complement virtual machines. This box right here really represents a VM. Now, why is this a faster deployment, no patching required, less downtime story? Like, what does that even mean? Well, as it turns out, containers have this interesting property, and that is that they're an actual image of SQL Server that can be any image. Now, SQL Server in the core, remember it's this core engine we talked about, it's smart enough to look at a database when it starts up, and within a major release, within cumulative updates, it knows how to upgrade itself. So cumulative updates are now compatible between each other in a major release. And in fact, they know how to downgrade themselves if necessary. So let me hit escape here and hit the button. If I want to patch SQL in a container, I don't really patch it anymore. I don't go run an update in the container. I don't update the SQL process. I just spin up another one with the new cumulative update I want, and I just switch it. I'll shut down the old one. I'll point the new one to the system databases and the user databases, and within 30 seconds, I'm up and running. And guess what? If that didn't work for me, I can switch back. I can shut this one down and go back to the other one. In the SQL workshops is that lab for you. You can go, if you have Windows, for example, or you have MacBook, you can easily run Docker on there. The labs show you how to do that. You have all the scripts to show you this switch method to do patching. And then faster deployment is because guess what? The containers are pre-installed versions of SQL already there. So when you start a SQL container, once you pull the image down, it starts so fast you don't even think it started. You're like, wait, that's not the SQL startup I'm used to. You're used to hitting a service start and waiting for a few minutes for it to come up. Not so much for containers. And then if you're thinking about DevOps and you think, can containers help DevOps? This is a link when you get the deck to a video of a demo I did at Build last year where I showed you how to combine Azure DevOps with SQL containers. It's really powerful stuff. You can build a GitHub repo of your code, and you can go into GitHub and just make a declarative change to your code. and then you can simply go in and commit those changes in the repo, and Azure DevOps will automatically spin up containers and run tests for you through your code. It's very powerful stuff for DevOps scenarios. So containers are really one of those. Now, David asked in here, when are we running one of these workshops? So Cecilia, is David asked that question?
No, I was asking David because David is an instructor.
Oh,
and we've been talking about
David
doing this for
question.
the community, and it would be amazing to do this.
Oh, I love it. I love it when I present and somebody else has to be on the hook to answer a question. I love that. That's a great way to run a presentation. Yeah, David, get on the ball there, man. So anyways, okay.
Oh,
so that's,
I love the SQL workshop is open, that GitHub repo that you mentioned, Bob. And yeah, it's an amazing learning resource. It would be cool to do a walkthrough as a group. That's phenomenal.
Thank you, David, so much. We worked really hard in 19, and unfortunately, to make you even feel more sad about in person, I was able to, right before all this shut down in 2019 at the past summit, I was able to deliver each day a 50-person in-person workshop, hands-on, where I actually taught people myself, walked around the room and showed them how to do all these things. So, but I think the GitHub repo itself is very self-contained and easy for to use. I spent a lot of time on Azure SQL lately, so I probably won't go back and do those again. But thanks for that feedback. I really appreciate that. Any questions on containers before we start talking about Azure SQL? Okay. Let's shift and talk about the public cloud a little bit, right? So, sorry, just one thing about containers I forgot to mention. Active Directory support has been added. We didn't have that before. A lot of people are asking for that. That now exists. We have that in our documentation if you need to do AD authentication with a Linux container. Okay, Azure SQL. Again, the branding of these three things. And if you're not familiar with this, let's just take a second to make sure you are. SQL Server and Azure Virtual Machine, think of this as being just like the VMs you run today. Azure just hosts it. We're just the host. We host the server, we host the network, we host the storage, you snap into that. We do have some things we've added to make it easier for you to manage, things like automated backups and security updates and so forth, deployment of marketplace images. But we have found customers that go to this method because they want to get to the cloud very fast. Great example. Customer came to us and said, our data center lease is expiring. We're not sure what to do. We need to get to the cloud. Like, we need to take 100 SQL servers and go to the cloud like in 2 weeks. Can we do that? We're like, sure. And they're like, we don't believe you. We're like, okay, we'll show you how to do one of them. And we showed them how to move. You can literally move the entire VM if you want itself. But we showed them how to move a SQL server and a VM into Azure VM very quickly and get up and running. So that is infrastructure as a service. The most control, but the less managed capabilities. Managed instance, Project Cloud Lifter, is the ability to have a full SQL Server instance available to you, but it's managed. What do we mean by that? Well, don't worry about the VM now. Don't even worry about any of that. You don't care what operating system we're on. You just get a SQL instance with full instance capabilities. Now, you don't access the file system or anything of that nature, but you get agent and resource governor and transaction replication, and it looks like a SQL server, and you manage it like a SQL server. But you get automatic HADR. And I'm going to show you a little bit of some architecture diagrams of one of the most powerful stories is auto HADR. And you get a wealth of other things that the cloud can provide by using this managed service. One of the other things you do that's really important is you get a private VNet. So you can now take your on-premises environment in a network and tie it into this VNet in Azure. You've got a private way of accessing SQL without exposing anything on the internet. Azure Sql Database is where we all started with Azure SQL many, many years ago. And it is just that. It is just a database. Even though it can feel like a SQL server in many aspects, the intention is you've got a brand new application and you want to go build it with the cloud. We think this is the right way for you to go because we're going to offer really cool stuff like serverless, hyperscale, and the most managed capabilities are going to exist here. So the two on the left are really meant for people moving from SQL Server on premises to the cloud. The one on the right, even though you can do that, is really more intention for building new apps that are cloud born. So let's do this. Let's kind of go through some aspects of Azure SQL. I'll show you a few little cool demonstrations. I'll show you something new you've never seen before. I just showed it this morning on Data Exposed. I'll show it to you here if you didn't see it, and then we'll answer your questions. So when you pick SQL Server today, you go through the process when you first install it of figuring out what's my VM size, how many cores, how much memory, what edition of SQL. You make all these choices to install it. With platforms as service, that's our managed service, you don't do any of that stuff. So what you do is pick something called a service tier, which affects some capabilities and resources to you. And the first one that we use both for database and managed instances is called general purpose. Just like the name implies, a lot of people pick this one. It's for just most workloads, right? Even though the storage of your databases is in Azure remote storage, you still have full HADR capabilities from it. Your IOPS are not going to be as high as they would from other tiers, but it's going to cost less money. And you're going to get an option called serverless, where you can do auto scaling and something really amazing. You can now set up in such a way that you're only going to pay for the compute you use. Whereas if you pick other tiers, you pick 8 vCores, you're going to pay for 8 vCores whether you're using them or not. Serverless gives you the ability to pay for only when you use the compute. You're going to get a primary replica, so no read replicas in this environment. You can extend that with things like GODR to get read replicas, but from a basic service tier, this is what it feels like. Then you have something called business critical. Business critical being, hey, look, this is an enterprise-based application. I need low latency transactions. I need super fast recovery, and I need readable secondaries. So what we're going to do when you pick that, it's going to cost you some more money, but we're going to put your database on local drives within the infrastructure to make it faster. So IOPS are going to be faster. You're going to get more IO performance overall. You're going to get in-memory OTP. And look at this. We're going to use availability groups behind the scenes to give you that availability. And one of these is going to be a free readable secondary replica. And then finally, for Azure Sql Database, only for database, think of this as kind of being in between these modes a little bit, but in a unique way. We're something called hyperscale, where if you need real big scalability required, especially in the read side, this is the way to go for databases. And we're going to use a tiered architecture of local and remote storage. You're going to get IOPS that are going to feel a little bit more than general purpose, a little less than business critical. But here's the kicker, unlimited storage. Today, general purpose and business critical do have limitations on the size of the databases. Hyperscale, we document on 100 terabytes, but you can go bigger if you needed to, right? And so, but look at all the diagram here. You get 4 replicas, 4 read replicas you get as part of going to this hyperscale environment. So this is kind of what it feels like at a higher level to choose, like what options I need for deploying SQL. In the resources that I'm giving you at the very end of this, man, if you want to go nuts on this, I'll show you all these crazy resources we have for you where you can really dive in and hear myself and Anna Hoffman describe all these things in depth. Let's just talk a little bit about some of the availability options you get with business critical and hyperscale. General purpose, it's in our training, you can see it as well. But business critical is interesting because in business critical, we're going to go behind the scenes and deploy and configure an always-on availability group. Wouldn't all of you love to get away from having to worry about deploying and configure an AG? That would be kind of nice, wouldn't it? Well, business critical gives you that. So just by deploying the database itself and saying, I want business critical, we do something like this. You connect to something called a gateway. That gives you the listener abstraction now. So no matter where your database lives, the gateway is going to redirect you to where your server is. That's really cool. That's very important. On the primary replica, we're going to keep your databases, all of them, on local drives. Then what we're going to do is we're going to spin up a bunch of secondaries, right? In fact, we try to keep 3 are created. We keep 4 around at all times. And your transactions are going to be synchronized. As soon as one of them says, I've hardened the log, we'll say, good, you're good to go. Because all we need is one of them to fail over to, right? And then we have automatic failover built in too, which is based on what we call our service fabric. So it's going to feel like the failover detection we do in Windows failover clustering, but we do it for you automatically. Recovery time can now be extremely fast, right? Because we're using availability groups, just like you have AGs today, we're keeping these things redone. And because we have accelerated database recovery on, failover is super fast. So think about this. You have fast recovery, you have connectivity abstraction built in for you, and you get a read replica. And then we'll go take it further. How about if we took and stored your backups in different storage and we made them geo-redundant? Now tell me anybody can go put all that together and maintain that in a simple way in your data center. I've run into so many customers in my career that try to go do this, and it's hard. And then we even go further than this. We have something called availability zones where we can split this up across regions for you to make you even fully protected. Crazy stuff. And you get this just by deploying and saying, I want a business critical. You don't even choose all this stuff. We're showing this to you to show the power of what you have behind the scenes. Now, hyperscale is really interesting. Hyperscale is this tiered architecture. In order to support this unlimited database size we're talking about, you can imagine if the database is really, really large, how do you do some of this failover stuff? How do you do restores for something that big? Well, this is how we do it. When you get a primary compute, we're going to introduce behind the scenes something called a cache, which is really a local SSD drive. Think of it like buffer pool extension, except it's better. So we deploy that on the primary compute for you. So a lot of your pages are served from the local compute or from the cache. Then we build a series of page servers, all using SQL Server. So if we can't find your data on the primary compute, we'll go to these page servers that have buffer pools and caches. And then finally, we'll stick your databases on Azure storage. Now you're looking at this going, well, how fast is that? I mean, you're not putting it on a local drive. Well, guess what? Because we're using this tiered architecture, you rarely have to go after the actual file because we're using these caches in between to serve your data needs. Now, the piece that's missing from this diagram is the log. To make this really interesting, we've abstracted the log, the actual transaction log, to be stored somewhere else. We even have a log service that can take these log changes and feed these caches and feed the secondaries. So pretty clever type technology that's tiered. And here's one of the really important facets of this. A point-in-time restore is extremely fast because we can use a technology called snapshots. So we've demonstrated like a 40 terabyte restore in like 5 minutes. I mean, that's insane, right? To restore a database that large. A point-in-time restore becomes extremely fast. Recovery gets really fast. And then here's the kicker. You get 4 secondary replicas if you want to. And Anna's demonstrated where she's added replicas on the fly to an app and it just starts scaling. So imagine you dynamically scaling a read app that you need just by adding replicas and declaring them on the fly. Pretty crazy stuff. Let me stop right there. I've just poured a lot on your brain about tiers and HADR architecture, again, built for you behind the scenes.
Bob, I have a quick question on hyperscale.
Yeah.
Is there any technical reason outside of the total size of the database not fitting back into business critical that we cannot migrate back out from hyperscale to business critical once you go one way?
Yeah, you just nailed the head. I mean, it's the biggest reason. It's also a little bit interesting to try to go take everything and put it back into the actual BC environment. It's about size, to be honest with you.
Yeah, but I mean, I'm just thinking like the majority of database. I understand that the purpose of hyperscale to be able to host a super large database, but if someone's well within the business critical tier, is there any reason? I mean, if it's stored in blob storage.
There are other reasons. The number one reason is size. The other reason is how we partition out this data. We have to stitch this back together. So we actually put these in files for you. One of the cool things about a hyperscale that's nice, but then causes this problem going back, is that you don't even declare like storage maxes or anything. We just figure this out how to split all this up for you. So stitching it back together would be
that makes sense. So you're actually storing it all sharded up. So that's correct. Why it's impossible to get it back together. Okay, makes sense.
That's correct. Cool. But I will tell you, but it's a great question. I will tell you this though, we want to do that. We still want to find a way to figure that out because we think people may need to be able to do that.
Got it.
But let me also throw one other possibility at you as of interest. What if at some point everything was hyperscale in Azure Database, not managed instance, but database? Sure. What if you didn't even declare the tier anymore? We just did this for you, and you didn't care.
Yeah,
that might be interesting, right?
Absolutely.
Yeah, I can imagine a world one day where we might say, you know what? If you want a new database in Azure Database, let's just make it serverless and hyperscale, and you just go. You know, that'd be kind of a cool thing. That people have to worry about some of those choices from a tiering perspective. But that's
the Elastic database realized. Yep.
Elastic database realized, exactly.
Yeah. Cool. Thanks.
You bet. All right. So one other thing to talk about when I mention the cloud is the value of the cloud. This is Bob's opinion. I mean, there's no term called value of the cloud. I just created this, right? But like, are there any reasons besides just all the stuff you talked about that you would want to go, besides the fact it's versionless, besides get all this built-in HA stuff? Azure Defender being a service in the cloud that can help protect your data. We'll look at that in a second. So imagine getting notification of brute force attacks or security or SQL injections across all your Azure SQL assets. Azure Monitor SQL Insights, we just launched this. How about looking at rich metric telemetry across Azure Database, managed instances, across all your databases, across your VMs, seeing it in one cohesive way? and being able to consume that without even using the portal, like consuming it in some other different fashion. And then again, I'd like to gain more performance with no code changes. So I think it might be kind of cool in my database if you guys could like auto build indexes for me. That might be kind of fun. So let's stop for a second and take a look at just a few fun demos here. Let's first look at Azure Defender. So this is Azure Defender on my subscription. And I'm just looking at over here at the security center across everything. Look at all this stuff this thing covers. One of the things I love what it does is look at security alerts. So you notice here, this is real. I didn't make this up. This is real stuff. Sql Injection Attack happened on my database. That I pre-created, I'll admit that. But this stuff I didn't make up. Somebody's trying to attack my SQL Server. And I can go find out details of who's doing that and where. Look at this Sql Injection Alert. This is somebody trying to run an injection piece of code. Maybe you've seen something like this before, where something looks like this. Somebody's trying to inject a string like on a where clause on a form of a web app. And my web developer probably didn't lock down and secure what he's checking of what's being put into that form. So somebody probably figured out that in this form, somebody's sticking in a value. The developer is doing a dynamic SQL statement to take a where clause, use the word where, take whatever's on the form and stitch it together. Well, you know what? I'm pretty clever. I think I'll just add this. And I think I'll get access to information I shouldn't. Like, how about all my databases on the server? Or what's worse, people can go, you can look this up. People can try to go drop stuff, all sorts of interesting things they can do. So this is an injection attack. The thing I love about this is an Azure database, but this is a virtual machine. So Azure Defender being something that works across all Azure SQL assets, and we're even pushing that down to on-premise. So we would love for you to use Azure Defender as a way to go protect everything you do with all of your SQL servers, and including, if I look back over here, vulnerability assessments. So this is pretty interesting stuff. How about I take the best practices of what are called benchmarks in the industry, CIS and FedRAMP, which are known security practices. We go scan your configuration, and then you go in there, and notice here, we can update these rules also where you can, constantly see new things. So I can go into any one of these SQL assets and go and say, oh, have you guys found anything that I should look at? And sure enough, across my databases, and a lot of people miss looking at configuration of their system databases. We can even do that as well. So that's Azure Defender. That's pretty good technology. I think that's pretty powerful and a value in the cloud. The other thing I said was Sql Insights. So look at this. This is right here, an Azure database. Let's see if I can have it up here. Notice in the last 24 hours, this database was getting high CPU utilization. And I'm looking at the Azure portal. Now, if I were to go look at the actual VM, you can do stuff like this. You can look at like DMVs to go see, okay, was I having high resource usage? Let me see if I go back here. Did I have one maybe a while back? Or yeah, I actually had one earlier. This only takes a certain snapshot, but I can go look at resource usage with T-SQL, but that's inside SQL. But if I want to look at outside SQL, I might use this Azure Monitor concept. So let's go back and look at that. This is just the basic metrics, but I want a richer experience, and I want to see across my Azure assets. So let's go do that. Let's go look at, let me go back over here. And this is something called Sql Insights. And what we do for Sql Insights, this is the overall monitor experience. We set up a VM running Telegraph, open source, and then you get to go say, here are the things I want you to monitor, and then you can go and click in and look at different assets. So, for example, I'll go back and show you that same monitor experience for Azure, for my Azure database. Let me get that one for you. Here it is right here. So this is that same database, except let's go back here, I don't know, 12 hours maybe or something. And I can probably see that same utilization I saw before, but look at all the other rich metrics I get. Memory, data IO, then it gets even really richer. I get to see other types of things, including like weight stats. This is pretty cool in a visual fashion. So I can drill in for a specific database and get a rich set of metrics in the portal. Or like I was talking about earlier over here, I can look at across all of Azure SQL assets. Like, this is pretty cool. I'd like to look at things across my databases. So how about looking at like database space across different Azure databases, and I can now see these trends. We'll even color code some things for you. Or maybe I want to see, I'm a developer, And I wouldn't mind seeing like transaction rates, batch requests per second across these databases, or even things like blocking or deadlocking. But I don't want just on one. I will see it across different things and compare and contrast them. And then if I really want to go nuts, kind of like you can do with Perfmon today, I then can go look at these metrics and I can go across just about anything you want to see. I don't know, page splits, page lookups, you name it. And I can run that across, like errors per second or something like that. And I can see this even here across, let's see, this is instances. But I can even do this. Oh, yeah, I can do this across my different databases that I showed you here. So a lot of rich metrics, but here's a great story here. These are the default, what are called workbooks we provide for you, which are visualizations. But we take the Telegraph data and we put them in log analytics. So you can create your own workbooks. You can use log analytic APIs to go against that and consume them and look at it any way you want. And we publish for you everything we do. So like right here, right here, this is a listing of what we've now documented. We just went to public preview for this. This shows you all the different things we do. And then in the Telegraph space, we've built an actual plugin where you can go look at the source code. It's all open source. So you can see how we're joining DMVs, how we extract data from them, how we aggregate them. And again, since it's in log analytics, you guys can customize and consume this in any way you want. The final thing to show you before we take some questions here is query performance insights and automatic tuning. So this is a visualization of a database to look at the query store outside the query store. So you know you've used Management Studio maybe to look at the query store or DMVs. This is the portal view of it, which is kind of cool. So I don't have to connect into the database to see this data, or I can get recommendations. So we can actually go help you build indexes. We can recommend indexes for you to build or drop, or if you want to turn on automation here, you can actually do that for that automatically. This is one of the most highly used functionality features for new developers that are building cloud-born applications. They quite frankly don't know much about indexing, and they need to get rich insight. I had somebody ask me a question, can I go at the query level to look at billing? And in a way you could, because you could go look at a bill for a certain period of time and then go use this query performance insights to say, well, which queries used up the most CPU that I'm getting billed for? So you could actually go do that kind of type rich look. So that's a look at Azure Defender, SQL Insights, and automatic tuning for Azure SQL Database. Let me go back to the window here and see what questions you put in here. Okay. So Jeff asked about hyperscale. What options are there for on-prem if we could do close to that scale if we're handling page servers? Jeff, today we don't have any architectures like hyperscale built on-prem. In fact, Azure Arc for managed instance is just using Kubernetes, although we're kind of evaluating with Kubernetes, could we do scaling with just that functionality in containers? I don't think it necessarily would be a tiered architecture, but we have talked about, could we bring the power of hyperscale on-prem to like a Kubernetes environment? And that's where we would go if we're going to try to build platform as a service capabilities. Arc is going to be kind of the one of the ways we might do that, because Kubernetes pods and containers give us the best bet to build an infrastructure like Service Fabric does in the cloud. And you also asked, are SQL metrics an extra charge? The only thing you're getting charged for is the storage for log analytics, because you have to build a log analytics storage account. And today, at least today in public preview, you have to deploy a monitoring virtual machine, which is running Ubuntu. We help you go through that process, but there's a VM that you pay for. You can use a very low-powered VM to actually do it, but it's the one that's running all the Telegraph code and doing all the monitoring queries. So that's answer that question.
You can use one for all your servers and databases then?
Correct. Everything I showed you, I have one monitoring machine doing all of that. Now, obviously, if you really get nuts on this and start doing a lot of those things, you may have to beef up the power of that VM, because now that Telegraph code is the one doing all these queries. But you can also even change, what I love about this, you can change like the collection intervals. Like you can make them really tight or you can make them longer if that's something you want to do. That would help reduce some compute time. You can create, you said, can you create your own dashboards for metrics? And the answer is absolutely 100%. Because these are log analytics, you can use a concept called workbooks. I showed you the different objects you can go pick from those. Once you set up your monitoring machine and you get it configured right, you can then go use workbooks to create your own visualizations. What I'm showing you that you get from here which is in the monitor blade. You go to monitor here, and then you pick SQL preview. This is default workbooks that we've built. And that you can't change those. You can customize and edit them just temporarily, but you can't change them. What you can do though is see examples of what we've done, and we publish that. We publish the examples of a JSON of what these workbooks look like. But you can create your own workbooks and consume anything I'm showing you here.
Are they real time or are they just snapshot point in time?
Well, it's snapshot point in time because it's all the Telegraph code is doing is running DMV queries against your assets, right? Now
and you're
it's
just
doing
looking
it
at the
in
logs,
a polling interval. What's that?
Right. And I was going to say it's pulling it, putting it in the logs, and you're just looking at the logs here.
100% the case. It is what it's in the end. You can do this yourself. You can build your own thing to go query DMV, some sort of remote piece of code. We've just built it all for you. We built Telegraph plugins, which we document in Telegraph's GitHub sites. We built all the Telegraph plugins. We built all the queries. We've built the automation and the ease of configuring this by going through our exercise of creating a profile, configuring your monitor machine, setting up which assets you want to collect. And this is in public preview today. We plan to make this a much simpler in the future.
Is there plans to do real time? Like if you picked certain metrics and build a dashboard, are you planning to have a real time option for that?
Well, define what you mean by real time, Jeff.
Okay, so pulled like every second or something while you're watching the screen type of thing versus, like some of the monitoring tools out there, IDEA, Redgate, SentryOne, they do pull intervals, and then once you open up the screen, you can actually see real time. Like it looks at it every second.
Well, this has auto refreshing. So if you see here, this has an auto refreshing capability, and right now it's 5 minutes. You can set up your own workbooks to refresh as fast as you want. So our collection intervals can go down to a second if you want it.
Okay.
And then your workbook could be built to go auto refresh it a second if you wanted to.
Okay.
Okay. How long are the logs kept for? You asked, Jeff. So that's configurable for you. Log analytics allows these things to be kept for years. Quite frankly, you have to pay for that storage, right? But Azure Monitor Metrics by default built into the portal has like a 30-day window. But if you create your own log analytics storage, it's quite frankly unlimited for you. Can you talk about the user community to help Azure team target the right balance of topics for certification? David, I'm not familiar with the DP203 one. I do know that we'll talk about resources at the end of the talk today for Azure SQL. Our Azure Sql Fundamentals, we've been told, helps people get certified for 300. People have told us that they can go and just take our training and just pass the course right away. I mean, they've actually said that to us before. I'm not familiar so much with the 203 one. Can you mention about tying the Azure cost to the top queries? Yeah. So Sri asked this question. What I meant by that is Query Performance Insight allows you to see query history and its CPU usage by query. So the billing shows you how much CPU you're using at a given time range. You can just go look and see, well, I got billed the most on April 6th. What queries were using the most CPU on April 6th? You can actually drill into that and at the query level find out which ones got cost you the most CPU. Storage is different. Obviously, storage is you're paid for your storage in many different ways. So trying to track which queries gave you more storage is a harder one. Certainly for compute, it's something you could actually do for sure. Okay, let's go ahead. I know we're close to the end of your time, so let me just wrap up real quick here and just talk briefly about cloud migration. I don't have any demos to show you today, but we have all sorts of demos coming up. We have something huge called the Azure Digital Event May 4th, I believe. I'll be on there. I'll be your host. Rohan Kumar is doing a keynote. I'll also do some demonstrations on migration you'll probably want to see. We've got a new Azure Migrate experience. We can now go out there in a VMware environment and we can discover over thousands of SQL instances and give you recommendations on how to migrate them. You can migrate inline. We're working on an Azure Data Studio experience so that you can just go through Azure Studio with a wizard, take a database and just move it to the cloud. And then we have a new thing that's really cool called Log Replay Service, where you can migrate online to managed instance without using database migration service. So you don't set up any service. You just go in, put your databases on cloud storage, and you might be doing that already in Azure Virtual Machine, and then you use Log Replay Service to do online log migration to a managed instance. And there's a great resource here called AKS Data Migration for you to look at all those things. And then finally, let's just end and talk about Azure Arc just briefly, and then we'll end our discussion today. And that is, we're just on this journey. We're just in public preview for it, but it's our intention to try to take, we have a Postgres option, but I'm focusing more on the managed instance side. It's our intention to take the power of Kubernetes and in your environment, in your data center, build a PaaS-like experience for you, a versionless SQL Server, auto HA, DAR, at some point get the thing like Elastic Scale, hook it up to the cloud so you can get billing that way. You can look at your assets in the cloud like I showed you here. You could then eventually do SQL Insights, Azure Defender, all those kind of type things. We call it Azure Arc Enabled Data Services. The SQL part is called Azure Arc SQL Managed Instance. Look for a lot more information from our team about this in the next coming months about what this is. It is in public preview though, so you can actually go play with this today. There also is something cool called Jumpstart. You can look it up, called Azure Arc Jumpstart. And they've got GitHub Azure templates to show you how to deploy this in Google, Amazon, Azure, on-prem, anywhere you want it. And so you can see examples of whatever Kubernetes you want, you can go deploy this. Excuse me, what a crazy time today, right? Excuse me. This is that crazy table I showed you. This is hot off the presses. Like I haven't even shown this to anybody else. And I'm not going to go over it. You'll have it in the deck when you go look at AKMS Bobboard MS. And by the way, I will upload the updated version on that site right after our talk here. But notice I'll just give you an example. If you want to lift and shift to the cloud, these are your two best options, right? If you want to do cloud-borne applications, maybe this is your option. If you want SQL Server instance full capabilities, these are your options. So the idea is to take certain scenarios and then pick which ones make sense for what you want to go do. And so we'll be iterating on this further. I'm working with my team right now to go through, do I have all the right options? If you go look at this on a deck and you have feedback for me, you have my email address, I would love to be able to tackle that. But you can see the intention here is you have so many choices run SQL, edge to cloud. When would I pick one versus the other? Going to the talk, you can get a feel for that, but it's kind of nice to see it in a more summarized fashion. So we talked about a lot of different things today, why SQL Edge is just a crazy, crazy way of seeing SQL's evolution from diskettes, right? All the way now from edge to cloud. And here's those resources I promised. Here's one right here, Azure Sql Fundamentals. Get ready for this one. The SQL workshop can be done for free, right? Because you get to GitHub, you pull it down, you install Dev Edition for free on your laptop. How'd you like a free Azure Sandbox? How'd you like that? How'd you like to do training for Azure SQL and not pay for it? We have that. You go to Azure SQL Fundamentals, you go through our labs, free Azure resources, and we have been told if you do just that, you can pass DP 300. And then we got crazy with this thing. Go to Azure SQL for Beginners. I don't have that listed here. That is 62 videos of Anna and I in little 4-minute chunks taking that same learning path and teaching you through videos. Or if you look at AKMS SQL workshops, it is all the GitHub versions of these. And why would you not do a shameless plug for your books on a call if you didn't list them? So I've been through this crazy journey over the last 3 years to write a book on Linux, a book on 19, and this last year, Azure SQL Revealed. This book is taking everything you've seen with us do Azure SQL and doing a huge deep dive. It was really my privilege also to have Scott Guthrie write the foreword for the book. And then if you're a developer, especially for new developers looking to get really up to speed quickly building apps for Azure Database, I recommend this resource as well. My colleagues all contributed to that book. So I'll go back and leave this screen up. Wow. Cecilia, is that what you're hoping for?
Amazing. Yes. Do you have a link to your presentation for people?
Yeah, so I put it at the top one, but I'll put this again right here. AKMS, I'll put it here in the chat window, Bobboard MS. There is a folder called SQL Edge to Cloud. Give me about 30 minutes. You're seeing the first updated version of this I've done. You're the first people to see this since I presented this a couple of months ago. So I'll take this updated version and upload that and put that up there in that same site.
Awesome.
Well, I want to thank you all today for taking time out of your evenings. I know it's like, what, 8 o'clock there, right? In East Coast. So I know you have things to do. You have your lives to live. So it's very, very nice of you to do this. And thanks for supporting your local user group and your community. You know, I told Buck and Reed from the very beginning, Microsoft may build the products, but we don't have nothing without you. You power us. And I really, that's not a marketing phrase, that's a truth. So I'm a big believer in SQL family and the community, and as a testament, that's why I'm here tonight to speak to you tonight. So keep rocking, stay strong, and thanks again for your time tonight.
Yeah, no, thank you, Bob.